Hi everybody, welcome to section 1.5 for algebra equations. Our objective is to solve equations with one variable only. They took out the two variables. This could quite possibly be the quickest section we do. Some of you are not going to like this because you're going to be frustrated. So let's talk about this. We're finally getting to talk about equations, and equations is a mathematical sentence in equal sign. Remember, expressions have no equal sign. All we can do is simplify equations. We can actually find solutions. So a solution is any value that makes an equation true. The equations we're going to work with in this section are going to have only one solution, but solution is a really big term and we're going to use that all year long. So anything that makes an equation true. And we're going to talk about true and falses today. A replacement set, in this case, is a set of numbers that I'm going to give you to substitute for the variable. I'm going to say, here's the replacement set. Here's the only numbers you're allowed to use. So don't be thinking you can go and use something else. Solution set is whatever from the replacement set that makes the statement true. And it does have to be from the replacement set. So we're going to just do some substitution. We're just going to do some order of operations and checking for true or false statements. So here's how your directions are going to look like in your homework. It's going to say find the solution set of each equation if the replacement sets are Q, 2, 3, 4, 5, 6, and S, negative 1, 0, 1, 2, 3. So notice in equation A, I've got a 2Q plus 5 equals 13. And notice how in equation B, I've got 28 equals 4 times the sum of 1 and 3s. So I've got q's in A and s's in B, which means that tells me which replacement set I'm going to use. This q tells me to use that. This s tells me to use that. So in this table over here, I am going to put in my 2, 3, 4, 5, and 6. Actually, you know what? Let me scoot those down one. Sorry, you can't do that. So here's my values of Q. Over here is going to be, is it true or false? And in the middle is where we're going to do the work. We could write the equation in there if we wanted to. 2Q plus 5 equals 13. So if we put a 2 into this equation, 2 times 2 plus 5, does that equal 13? Order of operations tells us 2 times 2 is 4, plus 5 is 9. That's a big old false. So I'm going to take the value 3. 2 times, instead of a q, I'm going to put a 3. How do you like this one? 2 times 3 plus 5, is that equal to 13? Well, 2 times 3 is 6. 6 plus 5 is 11, not 13. When I put a 4 in here, 2 times 4 plus another 5 equals 13. How do you like that one? 2 times 4 is 8, plus 5 is 13. So that's got to be a nice big true, which means, humor me, chances are 2 times 5 plus 5 is not going to equal 13, right? 10 plus 5. 2 times 6 plus 5 will probably not equal 13 because 12 plus 5 is 17. Yes, you have to fill in the rest of the table. And I forgot to say this, which we just did. Substitute the x values into the equation. Find the true statements. Some of you are going to find this frustrating because you're going to be able to solve that equation the old-fashioned way. But this is really more about replacement sets and solution sets. So our solution set for problem A is 4. So I'm going to put a 4 inside my swirly brackets. That's my solution set. The replacement set was 2, 3, 4, 5, 6. So let's do the same thing for equation with the s in it. So our s replacement set is negative 1, 0, 1, 2, 3. Over here is going to be my true or false. And in the middle 4 times 1 plus 3s. So we got a little bit of math, right? So we're going to plug those values in. So is 28 equal to 4 multiplied by 1 plus 3 times negative 1? Well, inside my parentheses, I'm going to do the math inside the parentheses and multiply that by 4. Or you could distribute if you wanted, or we could have distributed right away before we even wrote that if you wanted to do it that way. But 3 times negative 1 is negative 3, plus 1 is negative 2. Negative 2 times 4 is definitely not equal to 28, so I'm going to call that a false. I'm going to put in a 0. 28, is it equal to 4 times 1 plus 3 times 0? Well, 3 times 0, that's the multiplicative property of 0. So 0 plus 1 is 1, times 4 is 4, not 28. So let me try a 1. 28 equals 4 times 1 plus 3 times 1. Well, 3 times 1 is 3, plus another 1 is 4, times 4 is 16, not 28. All right, we're almost there. We got 2 more to try. Now here's, okay, never mind. I'll say that in just a second. 4 times 1 plus 3 times 2. Well, 3 times 2 is 6. 6 plus another 1 is 7. 7 times the 4 is 28. I got my true. So yes, humor me. I'm just going to put this in here. Since I got my one answer, chances are 3 times 3 is 9, plus another 1 is 10, times 4 is 40, not 28. We're going to have a true. Or we're going to have a false. We've already got our true. So my solution set is 2, the number that we substituted in order to get that true statement. If for some reason I went through my whole replacement set and I got no true statement, I would have to say, so if you get no true statement, I would have to say there's no solution that's based on the replacement set. There could be another answer that's not a part of the replacement set. So that's just where you got to be careful. And that's where some people who would rather do this by solving are going to get themselves into trouble. So humor me, go through the table. I know it's easy. And again, it's more about solution sets and replacement sets. So lesson summary. What's the difference between a replacement set and a solution set? And I'm going to give you the replacement set, -3, -2, -1, 0, 1. I would like you to find the solution set of 5x minus 7 equals -2. And that is it for section 1-5. Have a great day. Bring your questions to class. We'll see you later.